Alright, hello everybody, this is Dr. Tausman once again coming to you from Roanoke, Virginia. This is kind of the grand home stretch for recorded lectures. Once again, listen to these lectures, take the agenda, see if you can type out kind of a detailed outline and notes just showing me that you understand what I'm communicating with you in this particular situation. We're going to go in this last unit do something a little bit different. It won't be building on the ANOVA thing. We're going to talk about examples with correlation and regression here. So to start off, I've got an example on the agenda here, a little sleep apnea example. And let's say that I take, you guys know what sleep apnea is? It's when you snore, when you sleep. You're not getting oxygen and then you start snoring. And let's say, just for the sake of example, I take 5 people, I measure their weight, their BMI, and I also measure how many snoring episodes they have during an evening. Now, notice one really important thing here. I have the data here for those 5 people, and notice that both of these variables are continuous. BMI is a continuous variable, snoring is a continuous variable, because you can have all sorts of numbers here. None of the variables are categorical. You don't have level 1 high lights or low lights or obese, non-obese here. It's just strictly continuous variables. And when we have continuous variables, the statistic of choice, especially when we have 2, is a correlation, because a correlation can measure the relationship between 2 variables, especially when they're continuous. Now, what I did with this data is I put it in to make a visual representation, and actually you can see there a little scatter plot before you, and if you look at the numbers between BMI and snoring, it looks like there is indeed some relationship. And if you even look at the data set, as BMI goes up, so do snoring episodes. And we actually know this is true in the data set, that the more people weigh, the more likely they are to snore and have sleep apnea. In this case, snoring episodes are our operational definition for apnea here. So it looks like there is a relationship here. We run a correlation analysis, and if you look at the correlation results, hopefully you know correlations can range from 0 to positive or negative 1. The closer they are to 0, the more non-significant they are, and the more likely you are to say there is no relationship between these variables. If you look at the correlation run here, you can see that there is a correlation between BMI and snoring episodes. The correlation is very close to 1. It's 0.915. And notice it gives you a probability there, a significance of 0.029. And so this situation with a 0.915, close to being 1, you would say this is a significant relationship. And your real world statement here would be that as BMI increases, or there is a relationship between BMI and snoring episodes. As BMI increases, so do snoring episodes. Your APA of writing this, and I think it's chapter 15 of your book, you would write out the little letter R, and then in parentheses you would write in the degrees of freedom. Now if you have 5 points here, 5 pairs, for a straight line it's always n minus 2, so it would be 3, so it would be R, and then parentheses 3 equals 0.915, and then P equals 0.029. So make sure you write that out, statistical and real world statements. Okay, going down to D here, I want to talk about this idea that you may have heard previously. Correlations, although they are interesting and they show relationships, it's very difficult to interpret correlations as correlations as causation. So let me give you a couple of examples of that situation. Let's say that we know, for example, that people who watch TV that has a lot of violence it's correlated with behaving in a criminal way. So let's say we collect some data and we show that people who watch more violent TV also tend to have more higher crime rates, tend to commit more crimes. We'd like to say that watching TV causes people to be more criminal, but the thing we don't know there is we don't know if watching TV causes that violent crime to exist, or people who are simply criminals to begin with, who do violent crimes, simply like watching violent TV. So that's a problem of directionality. We don't know if A causes B, if watching TV causes violent crime, or if people who are violent criminals simply like watching violent TV. So because you're not manipulating variables systematically here with a correlation, you cannot determine directionality in cause-effect statements. Second issue, let's say that we do a study and we actually go and start measuring geographically how many churches there are in a given area and the crime rate. And let's say, just for the sake of example, we do that and we find that the more churches there are in a given area, the higher the crime rate. Would you want to be the one asserting that more churches lead to more crime? Of course not. And the reason for that correlation is actually true, but there's a third variable problem there. Where are there the most churches? Well, the most churches exist in the inner city, and we know that the inner city is where most crime exists. But that's kind of a third variable problem, that the highest density of churches is in the inner city, and it's the fact that you're in the inner city is why the crime rate is high, not because of the number of churches. Next situation is the example of a nonlinear relationship. If you look at the data example below, this is from the 1960s that looked at the number of riots and the temperature in the South during the 60s. And if you look at that data, you can see that as temperature goes up, at first the number of riots go up, but as the temperature goes to 90 and then it goes to 100, when it goes to 100, the number of riots goes down. You cannot run correlations when the relationship is nonlinear. This is a curvilinear relationship, so it's not appropriate to do it. And finally, the fourth one, and your book talks about this some, if you have an outlier, if all the data is non-related in a correlation sense, but then you got one outlier that shows the data is significant, you really shouldn't be running correlations when you have outliers. So use the book to add to your notes for this, but this is the first recording for correlations and causation, and hopefully it makes good sense to you. Thanks. Bye-bye.